Good morning everyone. Our project is a head gesture controlled wheelchair on a sloped surface. The contents of the presentation are objective, introduction, limitations of existing system, block diagram, implementation platform, advantages and limitations, applications, future scope, conclusion and references. The main objective of the system is to provide ease for the physically disabled or physically handicapped people's life who are not able to move on their own or make the movement of their body on their own in their daily routine of the life. So such a kind of people we have came up with the idea or came up with the idea to provide the ability to their disabilities. Introduction. The main aim of the system is to provide ease to the physically disabled people's life, the people who are physically amputees or physically challenged, like missing their legs and arms, paralyzed people. For such a kind of people, we have came up with the system that is automatic head gesture controlled wheelchair, who will be completely controlled by the head tilt motion of the patient who is sitting on that wheelchair. So the system is more flexible than the existing systems, and the system which is not able to not only able to work on the normal surface, but it is also able to operate on the sloped surface by controlling the speed of the wheelchair. That is the main feature we have added in our system. So the technology we have used here is an acceleration technology. In this, it is an accelerometer sensor, that is we have used ET06 is an micro electromechanical sensor used effectively translate the head tilt motion in the appropriate computer signals. Existing systems are there is eye controlled wheelchair or eyeball controlled wheelchair. There is an tongue controlled wheelchair. Another, there is a voice controlled wheelchair. These all systems have their own disadvantages. If you take an example of the voice control system, then if there is the system or the person who is a dumb, who is sitting on that wheelchair or using that wheelchair, who is not able to get the access of the wheelchair because he is a dumb, he is not able to talk, and also it is not suitable for the noisy environment. After looking for all these disadvantages, we have came up with the idea of the head gesture control wheelchair, which will be more flexible than the existing system. Here the block diagram of the proposed system. There are three inputs: accelerometer sensor, which will be sensing the direction of the head, slope detector, which will be sensing the slope of the surface, and the obstacle detector, which will be sensing any of the obstacle in the path of the wheelchair to reduce any accident probabilities. The main controller is an Raspberry Pi 3 controller we have used, and battery is a 12 volt 7 ampere per hour battery, which will be providing power supply to system. And there is two motors, BLDC motor and stepper motor. Stepper motor is used for direction control and BLDC motor for speed control. Implementation platform, as hardware requirements I have said here: Raspberry Pi 3 controller, accelerometer sensor, ultrasonic sensor, that is an obstacle detector, motor driver DRV8825, stepper motor and BLDC motor for speed and direction control, and lithium battery for the power supply. And software requirement is Python IDE, that is for Raspberry Pi 3 programming, and it is for the PCB designing. Accelerometer sensor is an device or the sensor which senses the head tilt motion of the patient, which will be converting appropriate head tilt direction of the patient in the appropriate electrical signals. The accelerometer sensor we have used here is an MPU6050 sensor, is an 6-axis motion tracking device. Obstacle detector we have used here is an ultrasonic sensor, which will be continuously sending RF signal based upon the obstacle. Whenever it arises, it reflects back the signal to the obstacle detector, which detects the obstacle in the path. Motors, there are two motors we have used. BLDC motor is a brushless DC motor for the speed controlling of the wheelchair, and stepper motor for direction control of the wheelchair. There are the motor driver circuits for the BLDC motor and the stepper motor we have shown here. Flowchart of the system. Very firstly, it will initialize the sensor and the system. Then it will check for the obstacle. If there is an obstacle, it will stop the wheelchair. If there is no obstacle, then it will check for the slope of the surface. If there is slope of the surface, based on the slope of the surface, it will decide the speed of the wheelchair, and then it will check for the head tilt direction of the patient who is sitting on the wheelchair. Based on the tilt direction of the patient's head, the appropriate direction of the wheelchair will be taken place. That is, for example, if left, then move motor in the left direction of the wheelchair. If it is right, then it will move rotate the wheelchair in the right direction, etc. Advantages of the system: increases the number of the disabled people in employment, low cost, good reliability, easy and flexible to use, and reduced accident probabilities, because as we have used here speed control mechanism. And limitation is this cannot be operated on the staircase surface. Applications is it is for the amputees, missing legs and arms, people who are weak or no body upper movement, and there is an paralyzed people, etc. Future scope: the scope of the system further can be extended for the staircase surface, as we have not done in this. And also we can make the system more advanced and reliable by using Raspberry Pi 3 controller. We can implement the IoT based system by using Raspberry Pi 3 controller. Conclusion: the intelligent wheelchair helps the severely disabled people in employment or leading their life in a simpler and easier way. The low cost assembly, that is this project cost is only within 30,000 rupees. By implementing such a kind of features like speed control and direction control, obstacle detection, etc., is only within 30,000 rupees. So people who are weak, financially weak, who are not able to purchase the costlier wheelchairs like 1.1 or 1.5 lakh wheelchairs are available in the market. So because of which we have designed such a kind of wheelchair within a low cost, which will be capable to buy for the weak or financially weak kind of peoples. This is the model of the wheelchair.